Okay, so today we're talking about multiplying exponents and then doing a power to a power, which is really just exponents to another exponent, right? So we'll kind of talk through all that. So the way that I want you to kind of think about this is a little bit like um, kind of combining like terms, except that we're only worried about the base of each term. We can separate all the bases out, right? So what I mean by that is if it's x squared, and then you want to combine that with an x to the first power. So we don't have to look at the powers, we look at the bases. Are they both x's? If they are, then we get to put them together. So this is what kind of multiplying is going to do. Now there's properties of exponents that kind of help simplify what we're doing here. But we'll kind of go through all the things and I'll slow it down as we go through each one, and then you kind of pick what makes most sense for you. I like the shortcuts because if we remember the shortcuts, then it just helps things out. So let's get started right away with this right here, simplifying. So here's what I want you to kind of take a look at. Let's look at number one here. Number one, it has a base 3 and a base x. So when I'm talking about base, I mean they separate everything that's kind of in that little group right there. So we got a number base, we have an x base. And it just says to multiply another number and another x, right? Again, so we're going to separate. So any bases that are the same, like a number base or an x base or a y base, whatever that might be, is allowed to get multiplied together. So let's just, for instance, say, since this is all multiplication, let's just kind of redo this and kind of rewrite it. So we got the 3 times the 2, that's kind of putting our bases together. And then let's kind of just group our x's, x times x, right? So that's kind of what that means. When you see an x, everything's got an exponent. So we're talking about a single x and a single x, a single 2 and a single 3, right? But now numbers are kind of their own thing. So if I was going to put these numbers together, it would be 6. And then if I was going to put these x's together, it's going to be x squared, meaning that I have 2 x's being multiplied times each other. So the shortcut is when the bases are the same, you just add the exponents and then rewrite it with that, right? So that's what it looks like. Other than that, the number bases, like when we have numbers and we have bases, we want to work those out and then multiply them together, squeeze them together like that. So that's kind of what this looks like. So again, here's kind of my basic shortcut is number bases together. Okay, 3 times 2, that's 6. And then x bases together, since they both have 1, shortcut is to add the exponents, 6x squared. All right, so that's kind of what that looks like. So let's go to this one right here. It's on you. You can pause it, you can do it, and then come back and check if you need to. Let's do it. So I have a base x and a base x. Let me slow it down for you real quick, because what does x squared actually mean? It means x times x. That's what x squared means. And then if we decide to bring over the other stuff, right? So then times x. Well, guess what? Each of these has an exponent of 1. We said the rule of thumb, the shortcut is add the exponents together as long as the bases are all the same. And so we got x to the 3rd. So that's what it looks like right there. So here's the shortcut. Let's just jump right up here. It's really x1. So if I'm multiplying bases that are the same, I just get to add the exponents. So again, here would have been the shortcut, x cubed, and we're good, right? Looks like that. Let's look at, let's kind of jump up a little bit, power to a power with this whole thing. So here's what I'm seeing here, just so that you're on the same page with me. I see a y base, I see an x base, I see a y base, but then we got this power to a power, right? And so this is kind of that, again, that the order of operations that says deal with the parentheses first. We always want to try to eliminate parentheses if we can to get rid of this. So what's in the parentheses with the exponent on it? Okay, so here's kind of what happens. Let me just do the y3 out here times, and let's apply this. I'm going to go and put the parentheses here, even though that's not going to necessarily do it. So let's just, for the moment, talk about what does this actually mean? Well, what it actually means is we got negative x cubed y negative 5 times negative x cubed y negative 5 times negative x cubed y negative 5 times negative x cubed y negative 5. Anytime you do something to an exponent, you're saying I want to see 1, 2, 3, 4 of that grouping. That's what exponents tells you. It's whatever it's connected to. I want to see that many of them being multiplied times each other. Well, if that's the case, base of x, base of x, base of x, base of x. As long as the bases are the same, what is our rule of thumb? It is to add the exponents together. Now you also notice there's a negative, then there's a negative, then there's a negative, then there's a negative. Negative times negative is a positive, times a negative is back to a negative, times a negative is back to a positive. So if there's an even number of negatives being multiplied, it's going to be a positive number. So then we're going to end up with x. Add these together. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So we're talking about x to the 12th. All right, let's do this. Y base. We're going to add all the exponents. Even if it's a negative exponent right now, just think of it as being added. Negative 5 plus negative 5 is negative 10, plus negative 5 is negative 15, plus another negative 5 is negative 20. Right? So there's what the final result of what that is trying to tell us. So what is the shortcut? Here's the shortcut. I'm going to rewrite this real quick. This negative here, I'm going to rewrite it as a negative 1 to the first power. Then we get x to the third power, y to the negative fifth power, all to the fourth power. So every base in here, the number base, the x base, and the y base, all have to go, it's power to a power, right? And so when we do power to a power, power to a power, power to a power, power to a power. When we do power to a power, we multiply the powers instead of add them like we do if we're talking about the bases being the same, but power to a power always is going to do multiplication. So what does that do? Y cubed times, all right, negative 1. I'll just keep this parentheses so you can see that I'm here. Negative 1, okay, its power is 1 times 4, negative 1 to the fourth. X, 3 times 4 is 12. Y, negative 5 times 4 is negative 20. Okay, so that's what that looks like, right? So there's power to a power. Multiply the exponents. And go ahead, do you see how I shifted that negative to call it what it really is, a negative 1, and then let its base also get that. So if it's a number base, it also has to get that exponent. Okay, here we go. Y cubed times, let's just work this out. All right, negative 1 times negative 1 is positive 1, times negative 1 is negative 1, times negative 1 is positive 1. So anytime we go to an even exponent on a negative value, it changes it to a positive. So we got 1 x 12th y to the negative 20th. Okay, now time to do the next step. All right, now as we look across here, I see a y base and a y base, and then no other bases that match up. So if the bases are the same and we're multiplying across on the same level, our rule of thumb, add the exponents, right? So then I'm going to have a 1 x 12 y negative 17. Okay, so that's really the answer there. But now the other piece of this is negative exponents. If we remember back from algebra, negative exponents just mean that whatever the negative exponent is attached to, in this case the y, it gets to move. And what I mean by move is always think about a fraction, right? You have the top of the fraction and you have the bottom of the fraction. So if something is on the bottom and it has a negative exponent, move it to the top and it becomes a positive exponent, and that gives it its ability to move. If it's got a negative exponent, it's on the top, it's going to move down, and then the negative becomes positive. So the negative exponent, only if it's on the exponent, not on the actual base, but on the exponent, it gets to move. It's like an elevator button. Click it, it moves down, it's no longer lit up, and you're done. Or if it's on the bottom and there's negative, click it, it moves up, and then it's no longer there. All right, so that's what that looks like. So here's how I'm going to do this. Know that every number, every expression can be written as a fraction. We just put it over the value 1. Okay, so I just call it like that. So now we see everything that's on the top and everything that's on the bottom, and there's only a 1 on the bottom. But this base y is attached to a negative exponent. Again, negative exponent, not the actual base itself. So what that means is I get to push the elevator button, which is the negative value, and this whole piece will move down, and the base with the exponent moves down, and then the negative goes away, and we got it. So here's what it looks like. If I do that movement, I got 1x to the 12th on top, and on the bottom I got 1y to the 17, right? The negative goes away, and it just tells me that I moved that whole base, and it's done. Now I'm going to clean it up a little bit, because 1 divided by 1 is 1, and usually when you have a 1 in front of a variable, we just don't show it, because we say 1x to the 12th, but really, yeah, the other way to say it is just x to the 12th instead of 2x to the 12th, which means that you got 2 of them. But this one, I just say I have 1x to the 12th. So it really gets simplified down to just looking like this as your final answer. Okay, so there's a lot going on there. Power to a power. Bases are the same. We get to add the exponents, no matter whether positive or negative. Negative exponents at the very end, we can move them up, or we can move them down and get them on the same level. So that's kind of what those are looking like there. All right, let's do this one. If you want to, you can pause it here. You can try it and then push play again and see how I work these things out. Okay, so what I'm going to do, I'm going to go ahead and simplify within and then take care, right? Because PEMDAS means parentheses. So if there's stuff to do within the parentheses, do that before then we go to that big exponent. You can do that. Actually, in this case, you could actually do the exponent first and it wouldn't matter, but I'm just going to go ahead and work a little bit on just getting this thing cleaned up a little bit. So base of y, and then, then we have our base of x and base of x, right? So as long as the bases are the same, we get to write that in. Now the first y I see there is just y. So I'm just gonna go ahead and say what the y is. It's really y to the 1, or to the first power. Bases are the same of the y's. Well, what is our rule of thumb? Our rule of thumb is add the exponent. So we're gonna go y to the 5th. Okay, there's 1. And then x's, and so everything's being multiplied, right? So multiplied just means this, right? Just deal with the exponents. X to the 8th. But this has still got a big 3 on the outside of it, right? So so that's how that we clean that up a little bit. So then we kind of, okay, we're here. So now we talk about exponent to an exponent. So power to a power, power to a power. So that means every base, no matter whether it's a number base or a variable base, needs to go power to a power. So then this would work out looking like this. Y to the 15th, we multiply when we go power, power, okay? And x to the 24th. And there's your answer right there. Now, what we would, if we're doing a multiple choice, we're doing Khan Academy, we're on some kind of assessment, you probably won't see it this way, because kind of the rule of thumb, the standard form for these things is to put it as if you were in the alphabet. So alphabetical order. So the X usually comes before the Y, so we just want to read it that way. So even though that is the correct answer that you're seeing right now, let's go ahead and just rearrange so that the X comes first and the Y comes second. And that would do it right there. All right, let's look at number 5. Ooh, boy, is there a lot going on here. So here's what I'm going to do, right? I like to clean up stuff first and then start dealing with the exponents on the outside. But notice this is a fraction, so things are already split. So we're going to want to keep the top on the top for the moment, keep the bottom on the bottom for the moment, and then once we clean up those, then we can start moving pieces around, okay? So stick with me on this one. Let's do this. So the first one on the top, so I'm going to draw my line here and just think about the top. So I got -2y, -4, 1. Okay, so remember, even a number gets an exponent, right? So now I see power to a power because I only see 2 bases in there, nothing to clean up on the inside. So let's go ahead and do power to a power, power to a power. So I'm going to get -2 to the -1. Okay, and then I'm going to get y to the 4th power, because -4 times -1 is a +4. Look at that. We just cleaned up the top. All right, on the bottom. Now this is kind of, we can clean up stuff in here, bases together, right? Add their exponents, but here's what I'm looking at on the outside, a 0. We haven't talked about this yet, but you might remember this from algebra. that anything to a 0 power, it does not matter how much junk is inside there. Anything to the 0 power is 1, right? So this is kind of the note or the rule of thumb. X to the 0 equals 1. Let's say we did 352 to the 0 power. Guess what? Equals 1. Anything to the 0 power. If we did x plus 8x squared minus 9y plus z to the 0 power, guess what it equals? 1, right? So it equals 1. So anything to the 0 power equals 1. So on the bottom, this whole thing simplifies down to 1. Boom, done, just like that, right? So it is done. So now let's take care of that next thing, right? Here, it's a number base, but it's got a negative power, right? What's the negative? Push the elevator button, zzz, comes on down, right? So let's do this real quick. I don't need that big of a line there. Let's say this equals, guess what? The y to the 4th, because it was not connected to the negative exponent, stays on top. And then the negative 2, now the power becomes 1 times the 1 that is still down there. I'll tell you, negative 2 to the first power is still negative 2. Negative 2 times 1 is negative 2. So y to the 4th over negative 2. And that's it. So this whole thing, which looked ugly early on, got cleaned up pretty quickly because of the 0 on the bottom. Okay, let's do this one. This one's not going to be quite as quick, but if you want to give this a shot, give it a shot, push pause, try it for a moment, and then come back and let's see if we can work this out together. All right, here we go. I'm going to take care of the top. So the top, I'm going to put a big, I'm going to give myself just a little more room here. Okay, on the top. So it's truly, right? Okay, let me interject here. Remember, a negative, I could always put the 1, right, which is there, so it gets its own power. So it's really negative 1. So let's just do it that way. So then I am going to get on the top negative 1 to the 3rd power, and I'm going to get y to the 6th power. Why? Power to a power, power to a power. That just means more power, power to a power. Okay, on the bottom, let's see if we can work this out. Number base, and actually here's another number base. Remember, anytime I see a negative, I could squeeze the 1 in there if I want. So number times a number, well, that's going to give me a positive 2. Y base, that means add the exponents, right? So I've got negative 7. And then x is by itself, right? I already took care. Remember, I kind of took care of the numbers already. I've already thought about how they interact with each other. So x to the 4th, I really should have written this differently so that this stays in alphabetical order, but I'll get it switched up in just a moment. Okay, so that's what that looks like right there. Now let's get right into this next part. I'm gonna work out this number right here. Negative 1 to the 3rd power. So it's negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is a positive 1 times negative 1 is back to a negative 1. So that's really just going to be negative 1 y to the 6. Okay. Let's just go ahead and rearrange this now just because I did that intermediate step. X to the 4th, y to the negative 7. All right, let's think about what does this mean, right? This negative value. So right now I got a y on the top and the y on the bottom. I need to consolidate them. But the good thing right this minute is that negative 7, I'm going to go ahead and take care of that piece, right? So the negative 7 is only connected to the y. Push the elevator button, it'll come on up to the top. So what do we got? Negative 1, y to the 6, and I just brought up a y to the 7, and the negative goes away because it got moved. So what's left on the bottom? 2x to the 4th, right? So that's what that looks like. All right, let's take a little trip down here, move it down. Okay, what happens here? So when I combine, since now base of y, and they're on the same level, we're just going to add those exponents. So I got negative 1 on the top, y to the 13 over 2x to the 4th on the bottom. Now, since it's own base y, own base of x, number, there's really nothing else we can do with those numbers. So we're just going to leave it like that. So this is actually our answer right here. Here's a little cleaned up version, negative 2x, or sorry, y to the 13th over 2x to the 4th. So that's what that looks like right there. Now, it's the same. If you want to keep it as -1, but I'm just saying if I'm doing a Khan Academy and multiple choice, you may not see the 1 hanging out there because, again, we say it like verbally, but we don't necessarily always write it all the time. When I'm talking about 1x, I can write 1x, or I can just write x, signifying that I have a single 1 showing to you. Same thing here with the -1 y to the 13th. So there's your answer right there. And then we will do a few more of these in class. All right, so there you go.